transformations of logarithmic functions. So a lot of this should look very familiar. It is very similar to the rules for exponential functions. There is an a as our coefficient in front of our log. Our b is a base of our log. Our c is the coefficient in front of the parentheses. So remember, if there is a number in front of x within the parentheses, you're going to have to factor it out first. Your h is always the opposite. That's why the negative is built in, and the k is whatever is being added or subtracted at the end. So this might be the fourth time you've heard a lot of this stuff. So take the time, pause this, write all this down. So a tells us a couple things. Is it reflected over the x-axis because it's negative? Is it vertically stretched because the absolute value, which means the positive version, is bigger than 1? Or is its positive version between 0 and 1, which means it is vertically compressed? So think of it like kind of like Play-Doh, you're pushing it down or pulling it up. The c value tells you if it's reflected over the y-axis because it's negative. If the positive version of c is greater than 1, it's horizontally compressed, and between 0 and 1, it's horizontally stretched. So that's going from side to side is the horizontal. Notice that just like the exponentials, the vertical stretch and the horizontal stretch are different. So like for the vertical, a is bigger than 1 for it to be a vertical stretch, but for it to be a horizontal stretch, c is between 0 and 1. So be very careful with your horizontal and vertical stretch and compress. H, we have to think of, again, our opposites. If it ends up being a positive number, it's moving to the right, a negative number is to the left. So said like x minus 2, that would mean h is a positive 2, it moves to the right. But if it had said x plus 2, then h would be a negative and it would move to the left. Think about your opposites. If k is positive, it moves up. If it's negative, it moves down. There's no difference there. It's just what exactly it is. If your base is greater than 1, your logarithmic function is going to look like this. So remember that logs are a inverse of exponentials. So when a base of an exponential is bigger than 1, it is an exponential growth, and it looks kind of something like this. And inverses are reflections over the line y equals x. So if I reflect that, it now kind of looks like that with my really bad drawing. If your base is between 0 and 1, your logarithmic function is going to go in that direction. So again, if this was an exponential and your base was between 0 and 1, it would be a decay problem. So it would look something like this. And if you reflect that over the y equals x line, it ends up looking something more like this. So your logarithmic and exponential are both kind of those curves, just going in opposite directions. Now the parent function of a log is your log base b of x. Everything else is gone. Nothing's being multiplied, added, or subtracted. It's just a plain y equals the log base of x.